Now these contacts don't just have a relative motion, they also have a relative speed. You could see it went from here to here. Not in reality, it doesn't mean it's in reality going this direction. However, compared to us, it went, contact A went from 8.3 miles away to 7.6 miles away. Contact B went from 7.1 miles away to 6.0 miles away. So if we wanted their speed, we could just measure the distance between those 2 points and compare it to the time that they went, the time that it took them. Remember, it's not going to be just 8.3 minus 7.6 because it's at an angle. 8.3 minus to 7.6 would be this right there, which is not necessarily the same as this right here. It is actually very close, but it's not exactly the same. And it's going to get more extreme the angle is relative to like the parallel with these bearings, the more different it's going to be. You know, that's a difference there of like 0.2 in terms of just, you know, the lateral direction away from the scope, but it's actually obviously a really large distance. So what we do is we measure M1 to M2. We take it over to our scale. Place it, I mean, you could place it at the start, but that's not helpful. Place it at the 2. It doesn't matter. As long as you know you're just measuring within a single mile, you could use any starting point you like. You could get, this says 0.8 miles. So we know that contact 1 sailed for 0.8 miles relative to us, not in reality, but just relative to us, sailed 0.8 miles from M1 to M2. And we know that it took 6 minutes to go there. So we could come here, mark off 6 minutes, and then these are not, anything under a mile is not clearly delineated here. However, these are tenths of a mile here on the logarithmic scale. So you can see here's 0.9, 0.8. So that's 0.8 miles right there. So if we connect the two, 0.8 miles in 6 minutes. Get it nice and clean. Gets us 8 knots. That shouldn't be a surprise. Again, 6-minute rule. That's why we use 6 minutes as our exact time to separation. We could have waited 5 minutes, and we still would have been able to do this just fine. However, it wouldn't have been as easy to do in our heads. I knew going into this that the answer was going to be 8, but using 6 minutes means that I can both do it in my head and on the paper, and if there's a discrepancy between the two, one of them is wrong, and I know that, and I can double check it. If I waited 5 minutes or 7 minutes, I wouldn't be able to double check the paper with my mind. That's why the 6-minute rule is so helpful here. Anyway, we now know that contact A has a speed of relative motion of 8 knots. So that's not the true motion it's going, but compared to us, if we were imagining ourselves as standing still, it would be going 8 miles, or 8 miles an hour, 8 knots, 8 nautical miles an hour, on a course of 194. It's not its true course and speed, but it's its course and speed relative to us. Now let's do the same for contact B. So first we just measure out its distance. So we connect M1 to M2. There we go. Get it nice and clean. There. Bring it up to the scale, and we get basically exactly 1 mile. It's like just barely under 1 mile, probably like 9.95, which, not even that, like 9.99. So we'll just go with 1 mile. So they sailed 1 mile in 6 minutes. I want you to guess what their speed is. We're still going to double check by using the plotting sheet. However, 1 nautical mile in 6 minutes gets us right there. And that is the SRM of contact B, 10 knots. So contact A has a relative motion or direction of relative motion of 194 and a speed of relative motion of 8 knots. Contact B has a direction of relative motion of 058.5 and a speed of relative motion of 10 knots.